Hello, everyone, and welcome to our Basic Developers Workshop for the Shopsys Framework. My name is Lukáš Heinz, and I'm COO of the Shopsys Framework. This webinar is designed for the developers to understand what the Shopsys Framework is, what's the history, what's about the architecture, and how to do the basic customization. So it covers all the basics, how to work with it, and after this webinar, you should be able to do your own customization and evaluate Shopsys Framework properly. Before we start, some organization matters. The webinar will take about 2.5 hours, and there will be at the end there will be place for your questions. If you have some questions during the webinar or during the presentation, you can use the chat. There is a special person in the chat. There's this question and comments who you can ask, and this is one of our developers, and he will provide the answers, or he will take over the presentation and he will explain it properly. I have to ask you one more thing. If you want the recording or the slides of this webinar, please write me or any other of our company your email and your company, and we will provide the slides, the recording, and also the feedback form so you can help us to be better. So now we can start with the webinar. From my part, the first thing I want to talk about is what the Shopsys Framework is, to cover its history, and I promise I will be really quick. The basic is that the Shopsys company works about 14 years. We already did about 800 of the e-commerce projects. From the beginning, we were doing only small projects. There wasn't a lot of custom modules. There was only the aim basic was to turn on the module and cash money. And it was nice, and at the beginning of this century, it was enough. But now we moved to another segment when we started building middle-size and big-size e-commerce projects, which started to be heavily customized, connected to ERP, and we have to maintain these projects long. The problem of our old platform was that there was a lot of turn-on modules, turn-on functions, and these big e-commerce projects don't need these modules. They need something else or another thing. So we left these turn-on modules in the code, and the code became messy. We didn't have any automatic tests or standards. So after 1 or 2 years, it happens that not a lot of developers want to work on this project. And we have to admit the old platform has its technical debt because it's hard to company itself to take care of the proper platform. So we was thinking what to do better. We wanted to work on a platform that was lean, that there wasn't so much functions, so much modules, that there are only basics. And for every customer, we will build the thing that he really needs, the things that are necessary for this project. And we want to be consistent and stable and long-term support. We did a lot of research, which platform to use. This was, I don't know, 3.5 years ago. So there was Magento, there was Presta, and it's not the thing that we really wanted. So we decided to work on, to build it from scratch. We decided to build it on up-to-date technologies that are proved and make sure that it's stable and long-term supportable. It means that there are automatic tests, automatic coding standard, and it's really modern. What can I say? What's our current state? We are now in the closed beta. The platform itself, it's ready for use. We currently built already 3 projects, 2 are still in progress, and 3 or 4 are now in queue. We are in closed beta because we don't have experience with open source projects and working with community. We have never do the product for someone else. It means that we lack the type of, we lack the skills to build documentation for others. So this is what we focused and why we are now in closed beta. We are expecting to go to the public beta in the fall of this year. So now we are still looking for several partners who will start building their own platform, and they will give us feedback to what they need in documentation, which features they really need, what they think about our architecture. And I have to say that we now have several partners. One of them is the biggest is a Patrol CZ, and they build big e-commerce projects on the Shopsys framework. And now, these are the technologies we build the Shopsys framework on. It's not cutting-edge technology, the most modern JavaScript framework of the month. No, this is the technologies that are proved, that are stable, and which are ready for enterprise architecture and enterprise e-commerce projects. But I won't talk about the technologies. I will pass the microphone to our lead developers, and they will present you the technologies, the architecture, and will take care of the rest of this webinar. So I will invite Mirek.
Hello. Welcome, everybody. I'm so excited that you are so many. So let me introduce myself and Petr. My name is Miroslav Šustek. I work for Shopsys for more than 7 years, and last 3 years we started to work with Symfony and to develop Shopsys Framework. Peter, can you introduce yourself, please?
Hi, everyone. My name is Petr Heinz. I am working in Shopsys for almost 6 years. 1.5 years of that on Shopsys Framework. Both of us are the main developers on this project, and we will alternate during the presentation.
Yeah. Before we start, I'm not sure if Lukáš mentioned that there is a chat in the Zoom application, and you can use it to ask any question, and whoever will be on the computer at this time will try to answer the question, or there will be a block for questions and answers in the very end of the workshop. Now I will go back to this slide for a moment, because I want to mention really fast what technologies do we use in Shopsys Framework. Yeah, I already mentioned Symfony, which is like the basic framework that we built Shopsys Framework on. We also use, of course, PHP in version 7. We use Composer for taking care of the packages. And I think 2 of the most important technologies that we use are Doctrine, ORM that we use for persistence layer, and also PostgreSQL that we use as a database. And this is the outline of today's workshop. First, I will tell you something about the system architecture. Then we will present you how will customization and upgrades be possible with Shopsys Framework. Then we will talk about some nice features and highlights of Shopsys Framework, something that you won't find in basic Symfony. After that, we will tell you how can you do automatic testing in Shopsys Framework, because Shopsys Framework is bundled with a few different types of automatic tests. Then quality assurance and development workflow, which is basically how you can maintain a good development cycle and how you can maintain the technical depth so that your code does not get old or mess. And last but not least is the live development demo, which will show you how some customizations can be done on Shopsys Framework. So this is today's plan. Now to the system architecture. What I want to show you in the very beginning is the structure, how the model of Shopsys Framework is structured. So let's go into PHP Storm. And as I already told you, Shopsys Framework is based on Symfony. So we go here into Shop Bundle, which is the basic bundle of Shopsys Framework. And here in the model directory, we find all the classes that are part of the model. You can see there is article here. There are things like customer, country, and so on. The important thing that you should note is how the model is structured. If I go, for example, into order, you can see that there is order, which is the basic entity of the order, and there are also some other classes like order data, order repository, order price calculation, and so on. So you can already notice that the model is structured in that way that classes that take care of one concept are in the same directory and same namespace. So you won't look for repository in a repositories directory where there will be all the repositories and entities will all be in one directory and so on. No, in Shopsys Framework, we structure the classes so that they are together by the feature or the thing that they take care of. What else you can notice is that the classes, we try to keep the classes and also the methods with intuitive naming that is based on a real-world vocabulary. Example can be order number generator, which is a class that, like it says, takes care of generating numbers for new orders. Or another example would be get sellable products in category, which is a method that basically returns you all products that could be sold from a particular category. These concepts are inspired by domain-driven design. Now, this is a different view. This is not how the classes are structured in the project, but this is actually an overview of the architecture from the layers point of view. You can notice that here on the left is the yellow rectangles are the things that are outside of the model of the application. It's, for example, controller, It could be some command line interface scripts. It could be a REST API or something else that is considered to be outside of the model. Then this big rectangle here, this red one, is called facade, and this is the name facade is used for a certain type of classes that are used as I would say a gateway or something like gateway to enter or to communicate with the model of the application. So basically, the controller should only work with facades to do its job and should not touch the internals like repositories, services, and so on. This is done so that the logic from the model can be reused across the controllers, command line scripts, and so on. Then I already mentioned repository, which is the type of class that is used to fetch objects from database. And when I say objects, I mean entities, which are here on the right. And then there are other types of classes. Entity manager, this is something that you probably know from Doctrine. And service, I should not forget about service. This is basically a class that should be independent of the persistence itself. You can notice that services do not work or do not communicate with things like entity manager or facade or repository, because these things, facades, entity manager, and repositories, they are dependent on the persistence layer. They can directly work with database, but services should be special kinds of objects or are special kinds of objects that should be easily testable, and therefore they should not work directly with database. But I will describe all the kinds of objects in more detail in the following minutes. So let's start with entities. Entities are the basic parts, basic type of classes used when you use Doctrine ORM. Basically, entity is a class that encapsulates the data. It should be persisted into database. It can contain some business logic, and we also think that the entities should contain the business logic when it's possible, because when the logic is inside the entities, it's the closest to the data as it's possible, and it's nicely encapsulated inside the object. What is like an interesting concept that we use for entities in Shopsys Framework is that we don't use anemic model, like entities that have setters and getters for every attribute, for every column that is in database. In this example, with the publish method, this is the example of the concept I'm talking about. Imagine that you have article entity and articles are published. And when you want to publish the article, you don't want to call methods like set status published and set publish date to some date, because these are two operations. And when you publish the article, you do one operation. You just publish the article and at a certain date, So instead of calling set status and set publish date, you should always create a method that is based on the actual use case that you do. So publish a method with date. And internally, there still can be the status and published date, like the attributes, but there should not be a public methods to set the status, because if you have such methods, you can actually get the object into some inconsistent state, like set the publish date to today, but set the status that it is not published yet. And this would be an inconsistent state that you want to avoid. So these were entities. Now, repository, as I already told you, is a type of class that takes care of retrieving objects, entities from the database. Repository will help you to hide the actual retrieving logic, like SQL or DQL from the doctrine. These queries can be nicely hidden in the repositories, and you will only have some public API, some public method that will retrieve the objects that you want, but you don't have to repeat the SQL queries and so on across many parts of the application. I will show you an example here in article controller. Yeah, that's probably it. I prepared some controller action that actually does not use our repositories from Shopsys Framework. It just uses entity repository that is part of doctrine. But as you can see, there is this not really nice part, which is basically some query builder, or you can imagine that it is SQL query basically. And yeah, I will show you what does this action look like in the application. Here, I clicked on news article, and you can see this is the page that we are talking about. Here in the developer toolbar, you can notice that it is really article on front end, article controller, and detail action. What it basically does is just that it retrieves the article from the database and displays it, passes the article to the Twig template that renders the article. I can show you the template. It's really very basic. There is some layout that is extended in the Twig so that we have the layout displayed, and basically it just displays the heading and the text of the article. Okay, let's go back to the controller and to the detail action. Yeah, it's a really simple use case, but you can already see that there is there is quite many lines of code for this simple task. And this is mainly because we don't use repositories in this example. And I will show you how to get rid of this part of the code, or not to get rid, but to actually move this part into the repository to get cleaner controller. So all repositories in Shopsys Framework, all the classes that are repositories have the suffix repository. So we can see that there is already article repository here, and we can look what methods are present in this repository. And I will show you that there already is the method, there already actually is the method that we want, and it is get visible by ID. So this method in article repository basically returns the article entity if it's visible by the past article ID. So let's go back to the controller, and now I can get rid of this code and use article repository, which is out-wired in this controller. This is something that that is not common in Symfony. That controllers are or controllers have the dependencies out-wired through the constructor. In Symfony, in Symfony, in a standard Symfony, you don't have this feature, but we use some bundle that can do the auto-wiring not only for the services, the basic services that you have in dependency injection controller, which is standard in Symfony, but thanks to this bundle, we can auto-wire the dependencies also in controllers. So yeah, we have already the article repository available here, and I can use the method that I showed you, get visible by ID. And here I just passed the ID, and I can already try it if it still works. Yeah, I just refreshed the page and it still works, which is good. So now you can see that I don't use the query builder and the query builder from Doctrine, but I use the get visible by ID from the repository. The good thing about this is not only that the controller does not have any SQL queries in it, but also that the logic for retrieving the objects can be reused. So you can see that here there is a get all visible query builder, and here on this line you can see the logic that that tells what it means that article is visible, that it is not hidden. So this is actually really great, because if somebody changes its mind and says that from now article to be visible, it not only means that it is not hidden, but it should also be published at the date that is in the past. So you don't have to go to, I don't know, 10 places in the application, 10 different classes, and change the SQL query so that it now contains the publish date, the condition for the publish date to be in the past. But you go to just one place in the application, you do the change here, and it works everywhere, because it's not duplicated. It is wrapped in the repository. Yeah, so now we are back in the article controller, and another great thing I wanted to show you is that now that we use article repository, the repository class, and not the entity repository from Doctrine, like the all-purpose repository in Doctrine, but this repository specifically created for articles, you can see that getVisibleById method has the return type specified in its annotation. So now I don't really need this type hinting annotation anymore, because it's already obvious what the type is, what the return type from this method is. Because with the general purpose entity repositories in Doctrine, you always get the interface is that does not have the specific type hinted, so you always have to use such annotations to tell the IDE, to tell the PHP store what type of entity you have. So this was another great thing about the repositories. And the last thing that I want to show you here in this example is that you may already notice that the method getVisibleById actually contains this this condition, this throwing exception when the article does not exist in the database. It's the same 4 lines that are now in the controller 2, so we can delete these 4 lines. And there is a rule for these methods in repositories for their naming that says that every time you want to retrieve a single entity, like article, for example, here, if you have get something method like getVisibleById, it always returns the entity, or it throws a not found exception when the entity does not exist. This is with this rule works for methods that start with get, and then there are methods that start with find. Let's see if we have some function find. Yeah, for example, here, find by ID. You can see in the annotation here that this method, find by ID, can return either article or null. Because when it does not start with get, but it starts with find, it doesn't throw an exception in case the entity doesn't exist, but it instead returns null. So this is a rule that you should get familiar with, because we use it in all repositories, and in some situations it comes handy when you have the exception thrown, like for example here, because when this method throws an exception, the Symfony framework automatically catches the exception and displays 404 error, like not found. But in some other situations, you may want to get the entity or null, and in case of null, you want to do some other thing and so on. Yeah, so this is the final state right now of the controller action, that we have article repository. We call the article repository, and we only pass this to the template. But it is not the really final state, because you may mention that you may notice that that in controllers right now we use a repository. But if I go back in this diagram, you can see that controllers actually do not have or should not have access to repositories directly. They should access the repository through the facade. I will talk about this. Well, actually, I will talk about this in the next slide. Let's just recap what repositories are for. So repositories are used to hide the actual or encapsulate the actual logic for retrieving the objects, and they can be used to put the logic, like for example, what it means that article is not hidden or is visible. You can put it on one place in your application. Now to the facades. So, as I already told you, facades are kind of objects that work as an entry point to the model. So you will use facades from controllers, from command line scripts, like from Symfony commands, and so on. Facades can talk or can work with persistence. It means entity manager, it means repositories, and so on. And facades usually pass the retrieved entities to services to do some more complicated, more complex logic that can be easily tested when it's placed in services and not in controllers or somewhere else. So facade is basically some entry point to the model. And what is good to know is that the methods of facade should have just one code path. Like it should not facade methods should not contain conditions like switches or ifs or so on, because you don't want the facade to contain some complex logic. You want the complex logic to be inside services that can be easily tested because they are not dependent on database. Yeah, we can go back to the source code, and I can show you just for the sake of correctness that we can replace the article repository get visible by ID call with article facade, and there is the same method get visible by ID. And if I go to this method, you can see that there is really nothing special about this method. It just passes here in article facade. It just passes the call to the article repository. There may be some methods that are not this simple, like only passing the work to another class. But as I told you, there can be some retrieving. For example, if you want to edit article, you need to first retrieve the article from the database, the entity from the database. Then you do the editing, and you can save it. So there are many more steps, but it should, as I told you, it should always be one code path, it should not branch that much and do some logic that would have to be tested. Yeah, and almost the last part of the architecture are the controllers. We've already seen the controller in practice. What I want to talk about now is what is the purpose of controllers in the end, when they should not contain the retrieving logic. They should not contain like the logic for editing, because this is wrapped in the facades and so on. So what are controllers for? Well, controllers are supposed to only handle the HTTP and HTML parts of the application, like the web-related stuff. They should not contain the business logic. because controllers are one of the hardest types of classes to test. Like you basically cannot use unit tests to test controllers. It will be very hard. And yeah, so controllers should not contain business logic. They should not directly access entity manager or repositories or services. They should only access the model through the facades. And the last type of object is are the services. What I didn't mention yet, but I should in the very beginning, is that services, in a point of view of architecture of Shopsys Framework, should not be confused with services in dependency injection container of Symfony, because these are two different concepts. Services in Shopsys Framework are basically classes that does not have any state, that does not work, does not talk to persistence directly, like they cannot access database directly. You only give them some data in arguments, like you give the data in the arguments of methods of services, and you get some result in return. And if you use this concept, you can have some complex logic, but easily testable by unit tests. Because when you don't have any external or global state like the database that is shared, and you don't have any internal state, you can easily reason about the code, because it will behave the same every time you call the method with certain arguments. It will always behave the same. So it is easy to test and to debug. And now, after I presented you the layers of the architecture, I want to tell you shortly something about the fundamental principles that we use when we develop Shopsys Framework. And first of the principles is single responsibility principle. I already presented you this in practice with the controllers and repositories. You could notice that in the beginning, when I showed you the repository that contained the query builder, this was a violation of single responsibility principle, because the controller took work of retrieving the object. It contained the logic for it basically contained the condition, what it means for an article to be visible, but it also took care of displaying the resulting HTML. It passed the object to the template and so on. So in the beginning, the controller violated the single responsibility principle, but in the end, we divided these responsibilities to facade and repository and controller, and all of them had just one responsibility. To sum it up, I talk about a single responsibility principle, which means that every part, like every class in the application, should have only one responsibility. And I presented it in the example of repositories and controllers that both have their own responsibilities. Another principle is dry, don't repeat yourself, which basically means that the same code should not be repeated in more places, more than one place in the application. And I also presented this concept with the repository, where in the end of the example, the logic for what it means that the article is visible was wrapped inside the repository, just on one place, not in the controller or in several controllers and so on. Another principle is you ain't gonna need it, which basically says that we should not develop features that we don't need right now. Like we should not develop something that we just think we will use in the future, because world is changing, and usually you will end up with code that you won't use, that you will actually won't use, and you will just spend the time for developing it, but in the end you will not use the code, because the circumstances will change. And how the principle is manifested in Shopsys Framework, it means that we, for example, we don't have methods in the repositories for all the cases, like find by ID, find by name, and everything. We don't have these methods until we actually need them. So there are no, basically, there should be no methods that are not called somewhere in the code. Yeah, this is just one example of the YAGNI principle. Another principle that is similar to you aren't gonna need it is KISS principle. It means keep it short and simple, and it says that you should not develop the features more complex than it's necessary. Like it's really similar to YAGNI when you sometimes may think that you can create some feature more complex to be more useful in the future, but by complicating the things, you actually can complicate the future, because the features will be so complex that it will be hard to maintain. And if the complexity is not necessary, then it's better to really keep it simple. And the last principle is developer experience, which is something like user experience for the users, but for Shopsys Framework, the users are developers. So we try to make the code and the product and everything around it as friendly as possible. So, for example, I don't know, when there is some exception in the application, it's not just like the message will tell you something went wrong and you will have to dig in the code and realize what the exception means and so on. But we try to always include some hints in the error message, so that you know what are the next steps, how can you fix the problem, what went wrong and why, and how to handle it. This is just one example of what developer experience means. It's basically that it's easier and more fun to work with the product. And now I will let Petr speak about the customization and upgrades.
Thank you, Mirek. Hi. So we will talk about architecture for a moment, but not about architecture in the point of view of classes, but architecture in the point of view of whole packages. For the main repository, which we call core, we decided for open box extensibility type, which means that if you want to customize the functionality, you fork the core repository and you maintain the code from that point on. This allows unlimited customization, which is not restricted by interfaces or provided options of customization. Also, this keeps low amount of indirection in the code, which means that it is easier to understand and maintain even for more junior developers. The indirection is basically delegation or some extra steps in the code that the path takes. It's sometimes wrongly called abstraction, and when the classes are extensible from the outside, which is called glassbox extensibility, it can mean that there is a lot of indirection, and it can be quite messy. But to be able to extend the functionality easily with some prepared modules, this is allowed by the plugin system. We are currently developing XML feed plugin, which would allow extending the eShop and to easily install a new XML feed, for example, the XML product feed from Google, just by requiring a package and registering it in the kernel, much like Symfony bundles work. This is especially useful for third-party service integrations, like payment gateways or some web analysis. As I said, the first plugin is currently under construction. To be able to reuse the plugins in the OpenBox core, which can be modified in any way, there are so-called plugin interfaces, which is a package that contains only interfaces files. It is represented here by the green circle. And the way it works is that your OpenBox core is dependent on the package with interfaces, and it implements some of the interfaces. The interfaces are read-only, are in vendor, so you cannot modify them, but you can easily modify the implementation in your project. These fixed interfaces allow the plugins to work independently on your changes in your core repository, provided that the interfaces are implemented and all the requirements are met. This allows you to easily install or remove any plugin as you wish. Other concept is components, and this is mainly to make some part of the project, some part of the code base upgradable, because with the open box extensibility, upgradability is an issue. Because you make the changes directly in your code base, the only way to upgrade when the original core repository changes is to merge or cherry pick the changes by yourself. To solve this issue, we came up with components. Components are type of packages that the core can be depending on, and they are in the vendor in the read-only state, just the same as plugins. We currently extracted a first component, which you can see on GitHub. It's called HTTP smoke testing, and it can be used in any Symfony application. I will talk about smoke testing some more in the next chapter. There will be more components, and extracting code from core into components makes it easily upgradable, because you can just run composer update and it will work. There will be some options to customize the behavior of components, so they can better fulfill your needs, your specific use cases. But as I mentioned earlier, this does not allow for really unrestricted customizability, because sometimes your use case is so specific that the pre-designed interface or configuration option is just not enough to make it work for you. In this case, you can always stop using the component and implement the functionality in your core repository, which is represented here by the blue customized data grid. Because the components are isolated from each other, this means that you can easily re-implement the data grid, change the functionality, and the other components will not be affected. In summary, there will be multiple packages, multiple repositories that will work with Shopsys Framework, or that will be the Shopsys Framework. The main repository is called core, and it uses open box extensibility, which means you fork it. When we make some bug fixes or improvements in the original core repository, we will announce it on our blog or in the changelog or in any other way. And if you decide you want them included in your project, you can cherry pick them or merge them. Later we will describe how we work with the history on Git. So to make this process easier, you can update your plugins and components that you use easily because there is Glassbox extensibility, and the files are read-only in Vendor, so you can update them by running Composer update. We will use semantic versioning, so the versions should be backward compatible, and it should not break your project when upgrading by a minor version. The detailed roadmap will be available around very soon. We actually wanted to announce it already, but there are some more tweaking we need to do. So we will provide a roadmap which will cover the extractions of code into components, plugins, and info about versioning. You can read more about the architecture and the reasons behind plugins, components, and the OpenBox core in our blog post on blog.shopsys.com. If you haven't read it already, there is an article which is quite long, but talks about this issue in more detail. So if you're interested, you can read it. And this is everything about the customizability and upgradability of Shopsys Framework. If you have any questions, you can ask them, and we can talk about it. Or if there are no questions, I can let Mirek talk about features and highlights.
Yeah, so let's change the topic to the features the features that Shopsys Framework provides, like the things that you will run into when you start actually developing on the Shopsys Framework. The first thing that I would like to mention is Think. Think is a build tool, something similar that's like Make on Unix and Linux, and it is used to do the some frequent tasks easily from the command line. So it can build the application in just one command, and it can also do many more things, which, for example, if you run in the command line think server run, it will run the integrated web server that can be used instead of Nginx, so you don't have to configure a whole stack on your local host, like the Nginx, PHP, FPM, and so on. You can just use the integrated server. Another command is think tests that will run the whole test suite, except acceptance tests that we don't run by default because they will pop up the browser and so on. So it could like interfere with your work. And there are many more commands that can be found in the documentation that is present in the repository of Shopsys Framework in directory docs, introduction, think targets. And there you can read about many other commands that will help you to work with Shopsys Framework more effectively. Another nice feature of Shopsys Framework is multi-channel and localization support. Multi-channel support is handled by using multiple domains, which means basically multiple front ends of the store. And thanks to this multi-channel support, you can have entities that have different values for some attributes for each domain. I can show you what I mean. Here we have the front end of the store, and this is the Shopsys with port 8080 is the first domain of the store, and there is also a second domain here in this demo. And if I go to 2.Shopsys with port 8080, this is first domain of the first domain of the second front-end domain of the store. That is in different language, and it has it can have different data for the entities, like for example the descriptions and so on. What is also important to mention that each front-end domain can have different language and currency. So there can be one currency on one domain and different currency on second domain, and so on. The localization, besides the basic things like translating static texts in a get text-like manner with using some T shortcut function. I will show you what I mean. Let's go, for example, to maybe article controller should contain, in administration, article controller for sure will contain some translated messages. Yeah, for example, here there is some error message, and you can see this T function. This is shortcut for the standard translator trans method that is present in Symfony, but you can use simply this global function that will provide you the same functionality. And this you can translate static text or text with some arguments using this function. And besides this, you can also translate entities the same way as entities can have different attribute values for each domain. Entities can also have different attribute values for each locale. Let's see how it looks in the source code. For example, product entity is the entity that has the data of the product. The product entity itself has some basic attributes like catalog number or part number and so on. But there are also entities called product domain, and product domain contains the data that are different for each front-end domain of the store. Like for example, CEO title, SEO title. You can use this multi-domain values, for example, for the SEO things, because generally you don't want the same content on different domains. So for example, the description of product should ideally be different on each domain. If the domains are in different language, it is certain that there will be the descriptions of the product will be different because they will be in a different language. But if you have two front-end domains that are both in the same language, you still may want to have different descriptions, because otherwise the search engines like Google can put your page in lower positions in the page rank, because usually the search engines don't like duplicated content. So yeah, this is the product domain entity that contains the data different for each front-end domain. And there is also product translation entity that is the same, basically the same concept, but it is the data that is different for each language, for each locale. So this was localization and multi-channel support. Yeah, I will also mention that there are some special form types for the multi-domain and multi-language data. These form types, well, let's go to product form type, so I can show you what I mean. Here in product form type, you can see, for example, that the name, this is the class that is used as a that says how the form for the product in administration will look like. So if you edit the product in administration, this class says how the form will look like. And you can see that we have name field, and the name is actually different for each language. I will show you. I will log into administration and go to the edit form of some product. And you can see that the name is different for Czech and English language. But here in the form, you don't need to do some special work for this. You just use localized type, which is prepared in Shopsys Framework to take care of this thing, and it will automatically enable you to edit the entity in all languages. This similar form type can be used for multi-domain data. Now let's talk about routing. Routing in Shopsys Framework uses few kinds of configuration, and first I will talk about the simplest way how to configure routes. I think it's the simplest way, and it's using the route annotation in Symfony. And this way is used in administration of Shopsys Framework. So let's go again into, for example, article controller in administration. And you can see, for example, here we have edit action that is used for editing articles. And here we use the route annotation that says what is the URL address of the route. So basically, this configuration enables you to specify the URL address for the admin page directly here in controller. On front end, there are three different types of configuration of routing. The easiest one is using for the simplest one is using a routing front YAML file, and this file is used for routes to pages that are not translated. So they are basically static and not translated, because it is configuration for pages that are typically AJAX endpoints. So you will use this URL in your AJAX request, but you will not display this URL address to the customers on the eShop. So they don't have to be translated in different languages. But if you have some URL address that is to be translated to different language, you will use routing front, and there are two different files right now. One routing front configuration for English and one for Czech locale. And here you can see that this file now contains the actions, the routes that which have URL addresses that should be translated. For example, here you can see from login, and the URL address is in English simply login, but in Czech it's prihlášení. What else? Yeah, this is basically what will you use routing front locale files for. And the last kind of way how routing is handled in Shopsys Framework is using so-called friendly URLs. Friendly URL is a concept that enables you to specify the URL address by the users. You can edit actually the URL addresses in administrations. For example, you can set the URL for different products so that they are not like I don't know, product/ID, but they contain the actual name, so it is easier for the users to work with these URL addresses because they know what the product behind the URL is. Yeah, these addresses are based on a slug. A slug is a term that is used for this part of the URL address that contains the name of the product or name of the article or any text that is used as the URL address. Right now, a friendly URL is used in Shopsys Framework for products, categories, article, and I'm not sure if it's the complete list, but you can easily add your own entities. You can use your own you can use friendly URLs with your own entities. The only thing you need to do is go to routing friendly URL, and this configuration file contains all the configuration for controller actions that use the friendly URL. You can see, for example, here the article detail. The path is actually just some placeholder. It does not matter what is here in the path because the actual URL is the slug that is set for the entity. And if I go to the action article detail, you can see that here is only the ID in the action. There is no slug or I don't know, product or article name or something like this, because the friendly URL automatically, the friendly URLs are automatically translated by Shopsys Framework into the entity into IDs or ID of the entity that has the configured Slack. So this was the last way how to specify URLs in Shopsys Framework. What is good to know is that the friendly URL can be, the Slack can be different for each domain, again, because you usually want to have different Slack, for example, when the domain is in different language. And another thing that is good to know is that you can have multiple Slacks or multiple URL addresses for one entity, but there is always one that is the main URL address, and the other ones, the other URL addresses are automatically redirected to the main one. So you can, for example, change the URL address to some different, and the users that will come, for example, through indexed search results from Google, they will go to the old address, will be automatically redirected to the canonical URL address, to the main URL address. So this was routing. And similar to routing, like you could, or to friendly URLs, in the similar way how you could add support for friendly URLs to any entity, you can add support for images to any entity. Right now, images can be uploaded to, for example, products, to categories, and so on. And I will show you images.yaml file. And this configuration file contains records or configuration for all the entities that can have images uploaded to them. So you can see there is, for example, payment, category, and here is product. And product also has this configuration multiple set to true, which means that product can have one product can have multiple images. And another cool thing about these images is that you can specify multiple sizes for the image. So each image that you will upload will be converted to different sizes, different sizes, and you can use these sizes on different pages. Like, for example, on the product detail, you want to have a big photo of the product, but in the product list, you don't want to load like the whole I don't know, half megabyte JPEG or something like this. If the list contains, for example, 24 products on each page, you want the images to be much smaller so that the list is loaded fast, for example, on mobile devices and so on. So you can specify a separate size for the product list and say that it has, for example, 300 by 200 pixels. Yeah, so these are basically the images, and the cool thing is really that you can simply add ability to upload images to any entity. Now let's talk about database migrations and demo data. First, database migrations are used to update the database schema to be compatible with the new object relational mapping. I will show you this in practice. For example, if I go to again to the article entity And here I have attributes like name, text, and let's say that I want to add another field, another attribute called description. Description. Now because I have these ORM annotations here, I basically changed the object relational mapping, but the database that I use is still the same. The database schema, the schema in the database itself did not change yet. So if I want to change the schema in my database, and also when I deploy the feature, the database schema should be changed in production environment. And when some other team member will will check out the feature from Git, he will also want to have the compatible database schema. So for this to work, I need to generate database migrations. So, yeah, so this should be the command db migrations generate, and this command will generate a new file with migration. And if I open this new file, you can see that it contains the alter table SQL query that will add the description field into the database schema. And now to apply this migration, I just run thing db migrations, and it will apply all the pending migrations. And right now, the field is already present in the database, and everything will work, and I can start to use this new description. So these are database migrations that are used to update the schema to the new version. There are also data fixtures, but data fixtures are not used to update the data. They are used just to load some demonstrational data, for example, or some testing data to the eShop. And yeah, the data fixtures are run after the database migrations. So when the schema is prepared, then the data is loaded by data fixtures. Again, there is a think command, db demo, and when I run this command, it will load all the data fixtures into the database. It will basically first drop the database, clean it up, and then create new database, update the schema with the migrations, and load the demo data. So if I check branch from some other team member, I can run this command, this db demo, and it will fill the database with the current schema that is needed for the features that the team member developed. And if the team member created some demonstrational data, which is a good rule, which is good to do, I will also have already the demonstrational data present, and I can test it, do a new feature, and I can play with it, and so on. And besides the features that I described in more detail, there are many other features, like, for example, data grid in administration that supports inline editing. There is file upload that works even if the if the form is already sent and there is some validation error, normal form will just forget the file that you selected for upload. But in Shopsys Framework, we have special file upload component that can, or file upload form type that can, or that remembers the file that is uploaded. And even when there is error in validation, the file stays in the form. So you don't have to select it again from this. There is also client-side validation, which means that forms are validated even before they are sent to server, because all the validation rules that you specify in the Symfony forms are translated into JavaScript validation rules that are validated in the browser of the user. Another feature is controller auto-wiring. I already talked about it, which helps us to keep the services YAML file smaller, because we don't have to register all the controllers in services YAML. Also, what you should get familiar with is the different error page that we use in Shopsys Framework. I can show you, for example, if I go to some non-existent URL address, you can see that the exception page is not the same as in standard Symfony. We use a different exception page, which provides some cool features, like you can see in the spec trace, you can see the code of the methods that are called in the call stack, and you can also see the actual arguments that were used in this process. So when I go to some more sane place where the arguments are not that complex, you can see, for example, that the HTTP kernel handle row method was called with some request that has with argument request and argument type with value 1, and the request can also be expanded, and you can see all the details. So this is really cool when you need to debug some unhandled exceptions. What else? We know that Shopsys Framework can handle database with 100,000 of products on single machine without needing to split the database to several places and so on. And it can handle this without using cache, because we think it is a good practice for the application to not be dependent on cache until it's under load. So if you have just one or few users, there is not a big load. The application should run without caching and without needing to deploy the application to more servers and so on. And the last cool feature that I want to show you is the responsive design. Okay, I loaded the demo database, but I didn't load the images. Yeah. Great, now we have the images too. The last thing I wanted to show you is the responsive design, which is present in Shopsys Framework. And if I change the size of the window, you can see that with each step, the content inside the window changes the layout so that it is usable also on the devices with smaller screens. You can, for example, see that when when the window is wider, you have the menu on the left. And if I change the width of the window to lower, like it's on mobile phones or tablets, you can now see that the menu is here. And when you click on it, the menu will pop up. So on front end of the store, the responsive design is by default. In administration, we don't have responsive design. You can use it from a tablet or so on, but it's not really responsive because we expect that the administrators won't use tablets to fill in the product descriptions and so on, because it is usually done from laptops or desktop computers. So it does not need to be as responsive as front end. So yeah, this were the features, some of the features of Shopsys Framework. And now Petr will tell you something about automatic testing in Shopsys Framework.
Okay, so I will shortly introduce you to the way we test on the Shopsys Framework. So first, slight overview. We use 5 different layers of tests. Each has its own focus. The first, the lowest level of tests are unit tests, which are great for testing the smallest possible amount of code. This is called the unit, and it's typically a method. Above it, there are integration or database tests that are running on testing database and can test more classes at once and can test persistence. Also, the third layer is HTTP smoke tests, which is done by our component, which I will show you. Then there are acceptance tests that are great for going through end-to-end scenarios. And then the fifth layer are performance tests that are running every night on the server and are seeing that the project is not having performance issues. So let's get to the levels in more detail. First, there are unit tests, and we are using PHP unit testing framework for it. As I already mentioned, they are testing the smallest possible amount of code, so-called unit, which means that the execution is really lightning fast, and they can really pinpoint the problem or pinpoint the error to the exact method that is not behaving as it should, which is a big advantage in debugging. And for isolating the tested units, you can use mocks, which is a special object that is behaving like a concrete implementation, but you can switch its behavior in the test directly, and you have absolute control of it. So you can easily inject some special behavior or isolate it from the database and for example, not really saving some data into the database. We can see the running of the unit tests by running think tests unit. And as you can see, it's really, really fast, and more than 700 tests ran under 6 seconds. I can well, let's go to the second level, the integration database test. Because even when you know that all the parts are working separately, it is not really guaranteed they can really work well together. And we can see examples from the real world. Because when you have two windows that each can work very well, but if you install it in this configuration, they just don't work. And a second example from real life is this perfectly working sliding lock installed on sliding door. So it's important to really test the application as a whole, not only every method of every class. The integration database tests are using a completely separate database. So they are not affecting application data. During running of integration tests, you can very well develop or click on the front end, and nothing is really changing for you. Because they are using completely isolated database. Even though the database are separate, it is still not really recommended to ever run tests in production environment, because well, even though database is isolated, for example, the file system is not. So if your classes modify files in the file system or delete some files or append information into log, this is something that will not be isolated, and you can damage application data. The tests themselves are isolated from one another using database transactions, which means that all database queries are rolled back. So every test starts exactly in the same starting condition, and you can run them in any order because they are not really modifying the state of the database. So this is great for easy writing of tests. The third layer, which is my favorite, is HTTP smoke test. And the concept of these tests is very simple. The testing component gets all the routes from the application router, then make a request for every of these routes, and just assert that the correct HTTP code is provided. So if it has a route for product detail, it can assert that it returns 200 OK. If the detail of the product should be hidden, it can assert that 404 not found is provided. The basic use case of this testing layer is for unhandled exceptions, because when you modify a part of your application, you may end up with unhandled exception somewhere else in the application, because you didn't realize these two places are connected. So this layer is really great for when you want to have some degree of assurance that everything is correct with minimal maintenance, because this layer almost works automatically. When you add a new page, and we will do this at the end of this workshop. When you add a new page, the component automatically assumes that it should return 200 OK, and will test this when executed. If you want to assert some other HTTP code, or if you have to provide some parameters like an ID, or you have to authenticate to see this page, you would have to configure the HTTP smoke testing component. I will show you the documentation. If you would like to modify the configuration, you can see the component on GitHub, and there is a documentation which explains how to do this and how you can use this component to better test your application and configure it for your specific routes. The fourth layer of testing are acceptance tests, and we are using Selenium for this task, along with Codeception and Google Chrome browser. We were using Firefox in the past, but the Chrome browser is really faster than the Firefox in this case. The acceptance tests allow end-to-end testing, and it uses a real web browser for the testing, so it can cover errors that occur only in it. For example, JavaScript code, or it can even test a case when you have some design issue in your templates, and for example there is some well, imagine that the button proceed to checkout is covered by some other element. This would mean that any user that wants to proceed to the checkout would be unable to do so, because he wouldn't be able to click on it. As well as the real user, the acceptance test wouldn't be able to click on it either. So the test of order submitting, order creation would fail, and you would immediately see that there is a problem with it. The disadvantage is that they can take a while to execute. We can see that. I will run the Selenium server, which will allow me to use acceptance tests. You can see here the Selenium server running. And I will just run things test acceptance. And you can see that the database was dumped to be reused after every test case. And now there will be Google Chrome browser open. And all the testing cases will run in it. And you can see it can test that administrator can filter products by catalog number. It will test that admin can log in correctly into administration. But it will also test that the admin cannot log into the administration when he is using a non-existent username or a bad password. Because it is important to test not only the correct states, but also test the behavior of the application in the incorrect states. You can see that each of the scenarios takes a while because there has to be the database restored, etc. So there is a slight overhead. But these tests are very, very powerful. So okay, because we don't have the time to see all the scenarios, all the 28 scenarios, I killed the process, and now I have to remove a file called test in the root directory, or else it would run in test environment. You can read more about tests in the documentation, in the docs folder, in the root of the project. Next layer are the performance tests, and they are working very similarly to HTTP smoke tests. But their core functionality, their focus is different. In the same way as HTTP smoke tests, they are taking the router, extracting all routes from it, but they are measuring the response time as well as the HTTP status code. This means the performance test can assert that the actions do not take too long. Before the tests are actually executed, the database is filled with a large amount of data, like tens of thousands of products, tens of thousands of orders, thousands of customers, because these are the numbers we are typically encountering in production environment of a big e-commerce project, of a big online store. This is quite important because when you are developing on the demonstrational data, you can make some feature not really well performing on a bigger amount of data, because almost nobody develops an application with a copy of production data or something similar. because that would be very slow during the development process. So even if you are working on small data set, you will not slow down the page because the performance tests will tell you if you mistakenly do so, and you can repair it afterwards. These tests are running on our server. We are not running them on our local machines because they are taking too long, especially with the data import. Generally speaking, the automation of tests is extremely important because ideally the tests should execute themselves automatically without the developer needing to execute any task just by pushing his commits into a remote repository. This is done by a continuous integration server. The test provides you with some sort of safety net. They can assure you that the refactoring you made did not break any functionality in the other parts of the application, and the automatic tests are really important when you want to make changes and not be dependent on manual testing. The different layers of testing were designed so that we can well balance the amount of test coverage, because when you have big test coverage, you cannot make changes to the code easily. But also, if you don't have any tests, you can very easily break some important functionality, and you should test everything manually then, which is very expensive and time consuming. So, well, write tests. And Mirek will now speak about code quality assurance.
Yeah. So the code quality assurance is important for many reasons. One of the reasons is that Shopsys Framework is designed for teams of developers that will work together, and especially if you have somebody new in the team, you will need to you need the new person, the new developer, to get used to the coding standards and all the rules that you use. And the tools that are present in Shopsys Framework will really help you with this. We use many tools for not only for checking the coding standards, but also for fixing coding standards, and also for assuring the code quality. Like, for example, the maximum length of the method is limited, because if you have too long methods, it usually means that the code is not separated properly, and it can easily become a mess if there are no limits for this. So let's talk about what the tools for coding standards can do for you. It can check the syntax errors, the formatting errors, like when you misplace braces or something like this. It also can detect too complex control structures, as I already said, when a method is too long, or when there is too many nested conditions, too many ifs, and something like this. Or it can even do some type checks statically, so that you don't need to run the code to know whether all the types are compatible. It can detect dead code and so on. I will show you an example. Very basic one. For example, what is important to know is that Shopsys Framework uses PSR2 standard, which is standard for PHP applications, and many projects, including Symfony doctrine and so on, uses this standard, this coding standard, and it says, among the other rules, where the opening brace, where the opening curly brace should be placed for methods. And now, if I place it here, which is not the right place, and I run the think standards diff target, what this will do is that it will check all the files that are changed, that were changed since the origin master in Git repository. That means all the changes that are done in my branch will be checked for the violations of coding standards. And here you can see that PHP CS Fixer says that the braces are placed on bad place. And as I said, many of the rules, not only the tools not only detect when the rules are not obeyed, but the tools can also fix certain problems with the coding standards. So now that I run the think standard fix command, it automatically fixed the code so that it now adheres to the PSR2 standard. As I told you, there are also checks for example, dead code and so on. So I think that if I, for example, have return some value here, and some code here, for example, I will call this down function or something. It needs the schema. Well, let's call just, I don't know, random 110. It will tell me that there is, there is one violation now, that I use wrong quotes for the ASDF string, but it should also warn you about the dead code that is not run because it's after the run the return statement. Yeah, so as I said, the coding standards checks and the code quality checks not only helps you to maintain the quality of the code, so it does not get a mess after a while, but it also helps you to focus on the things that are really important, and not to argue with your with your teammates about the coding standards and so on, because the tools can check the coding standards and fix them. So you don't need to explain that, hey, the brace is placed on the wrong place and so on, because this is everything done automatically. And now I would like to talk about the development workflow that we use when we develop Shopsys Framework, and similar workflow can also be used when developing e-commerce, when building stores on Shopsys Framework. Again, it is based on the thing that the Shopsys Framework is meant for teams, and therefore we use Git versioning systems for the code, because it supports a lot of the features that can be used when developing in team and co-working with other persons. What is important to say is that in Git, every commit message should be descriptive enough, so that the other developers that read the commits that you create should know what happened and why it happened, what change happened and why it happened, just from the commit message. And there should not be a need to ask somebody else, why did you do this change and so on. So it should be all in the commit message ideally. And also the commits should be small, not a big like commit bombs that will contain changes in hundreds of files, because what we try to achieve with commit messages is something similar to single responsibility principle. That each commit should do just one change, one simple change, so it is easy to understand what happened in this commit and why. Because when you change many files in one commit, it can be really hard after some time for you to remember why you did all the changes, and for the other teammates it will be even harder, because they will not have the background, why did you do all the changes and so on. So the history in the Git is really important. Yeah, it's also important for us to keep the history really clean, because the core of Shopsys Framework, the main repository that will be forked to create the customized stores on Shopsys Framework, will not use the Glassbox extensibility, but OpenBox, which means that you will fork the repository, and you will, if there will be any bugs or any bugs in the repository or any new features, you will need to merge them or cherry pick them manually, and the clean history in the Git will help you with this. For the components and plugins, it's different, because then there you can use composer update, but just for the core of the Shopsys Framework, you need to be able to read the history and know what changes happened there. Besides from Git and communicating through the code using Git, we also use continuous integration server, because every feature that we do, we develop this feature in a separate branch in Git, and when we push this branch, it is automatically built on a continuous integration server that we use. And the build means that it will check the coding standards and the quality of the code automatically. It will run all the tests, and it will also fill the application with demonstrational data and prepare it so that it's accessible through the web. And for example, testers can test the application, or product owner can check whether the feature that is developed is right and it's developed in the way that he or she wanted. And when there are any problems during the build, the continuous integration server automatically reports the problems to the developers and they can fix them. It is really important to develop the features separately in Git, in a separate branch, because only then you can focus on your only on your feature and not on the other work that other developers do. And if you have a team of many developers, of 3, 5 developers, you really want or need to use branches to separate the work and so that more people can work on the same code base at one time. So this was about the development workflow and quality assurance and coding standards checks. And now, in the final part of this workshop, Petr will show you a live demo how to do some customizations on Shopsys Framework.
So we are all developers, all programmers. So now it's the time to see the code and try to do something real with it. So our task that I will show you how to do will be to create a new page. Imagine a store that is selling consumables, for example, diapers or pet food, etc. Its users often return to the store and make similar orders because they ran out of what they bought. So let us help the registered user with this task of repeating orders by making a page that will list all his recently bought products. Modification like this can increase both store revenue and customer comfort. So it is a good thing to do. And if you would like to go through this modification yourself, you can look into the documentation, because there is a cookbook written on the same topic. So let's start. I will first have to revert all changes that were made. So I'm going to revert it in Git and delete the migration file that Mirek has made as a demonstration. And I will run task db demo, which will rebuild the database so that the changes that were made by the migration wouldn't be in the database. So I can start while this is running on the background. We will start in the controller, because the controller is some sort of gateway to the eShop. So I will look for a product controller on the front end. And now I will create a new action. So let's write a public function. We will call it recently bought action. And this public function will do nothing else but just render a new template. I'm going to copy this path, but rename it to recently bought. And because I have installed and enabled Symfony plugin in the PHP Storm, it allows me to create the template very easily in the resources folder. You can see here resources, views, front content project. This is the path of the template. You can see it extends the layout with panel, which is great because we want our new page to look exactly like this, at this left panel, header, footer, in the sake of consistency. Now we will write some title. So ideal title would be recently bought products. And to allow localization, I will use trans filter, which will translate this string to the current locale. And for the main content block, I will just add heading, which will say your recently bought products. And here we will have information about not having any product really. So you don't have any recently bought products. So now we have a template. We have an controller action. What we need now is a route for the new page to have its own URL. So we can look to the routing front TS and routing front EN, and we can add some new route. So we can call it front product recently bought. This will be the route name, and route path will be slash recently bought slash. So in the controller, I've created a new action that just renders a template. I created a new template that extends the layout with panel so that it will share the layout with other pages. I've made translatable title for this page, and the main content contains only heading, also translatable, and a message that there are no products at the moment. For the page to be accessible on the web, I have to define a route. So I went into the routing front EN YAML, which Mirek talked about. And here I created a new route named front product recently bought. This will serve as an identifier, so I can, for example, generate a path for it. And the path is /recently bought. And here is the controller action mentioned. I copied this route into the routing front CS to make check translation. This will be called. This will be nedávno nakoupeno. Okay, so now we have everything we need for a page. We have almost everything we need for a new page. But there is one thing missing, because when you have a page that is displayed with the default layout, there is also always this breadcrumb navigation rendered here. So to make it work with our new page, we will go to the breadcrumb generator, and because we don't have to make this logic really hard, we can use simple breadcrumb generator. Simple breadcrumb generator really works like a simple map from route name, front product recently bought, to the breadcrumb item label. So recently bought products. This T function is the function to translate a string. It's similar to the trans filter in Twig. And now we should be able to go to the recently bought page, and we can see that we don't have any recently bought products. But the page is loaded, and you can see here the breadcrumb navigation. You can see here the title, the layout, everything works as expected. But for this dummy page to be complete, it should have a link to it. So the functionality is meant to be for registered user. So we can register, we can log in as a demo customer, no reply at netdevelop.cz with the password really demonstrational, user 1234. And this is not correct. Why is this not correct?
It's user 123.
User 123. Nope. This is weird. Should work. I'm sorry, there was some problem with the credentials, but I've managed to log in. I made a typo probably in the email. I've managed to log in as Jaromir Jager, and we can see this client menu. And it would be great if there was a third link to exactly this page, recently bought. So we can do that. We can do exactly that. in the header HTML twig file, which is the template of this header, we can find the menu that is rendered there. It's this list, and we can add a new item. And as a URL, we will use our from product recently bought route, and we will change the label to recently bought. So now, when the menu is rendered, we should see our new link to our page. And everything works. Great. So for commits to be really atomic and to have only one modification, as Mirek told, we should make a commit now. So a new page for recently bought products of registered users. No products are listed. Yeah. Okay. We can commit it. Great. And now we can focus on actually displaying some products here. So we can start in the repository, because we know that all the data from database are loaded by repositories. So we can go to the product repository, and here we can make a new public function, and this will be called get recently bought products. We will definitely need a user to be provided. That should be enough. So as a parameter, there will be a user, and it will return array of products. This we know already. So now we should write the query builder. We can use a query builder that is already implemented, because we want to display all visible products. Similarly, as Mirek showed with the articles, there is a query builder for visible products. For this query builder to be provided, it needs an ID of the domain and a pricing group, because the visibility is defined by both of these attributes. Luckily, the user has a getter for the domain ID and also for the pricing group. So this data can be provided from the user entity. This query builder, we want to select the products that are mentioned in the orders of the user. So we have to join some new entities. we will have to join order product entity, which represents an item of the order, and it has product attribute, and it has also an order attribute. We will use this in the joining the relations. So we will join order product. We will use an alias OP. We always use initials as aliases in doctrine query builders. So we will use OP. We will join this with and the attribute product of the order product has to be equal to the product of the query builder itself. We know it's an entity product, so it has alias just P. And because we want to put there a condition on the order itself, we have to join the order entity as well. But we can join this by its property order and alias it O. Now we can finally add the condition, and we are using and where, not where, because there are already some conditions in the visible query builder, and we would override it. So and where is the method we want to call. When we look to in the order entity, we can see that that it has a column named customer that can be either a registered user or null, meaning it was bought by an unregistered user. So we want to say that the customer is equal to user and provide the parameter user like this. For it to be in a reasonable order, we should order it by date of creation. I think it's created at. We can look into the order. It's created at, and it's a date time. So we can order it by created at in descending order, so that the most recently bought items will be at the top. And now we can just call get query get result. And this will be the array of products we want to return. Let's now look into the product controller. We cannot use here our repository, because there is well, you should use facades in all controllers. So there is already a facade here wired, and it's named product on current domain facade. This facade is special in a way. It knows about the context of the current domain and currently locked user. So we will peek into it. product and current domain facade. And here we should make a new public function. Public function get recently bought products. It will have no arguments because it already knows the context of the logged customer, and it has the product repository already wired, so it can get all visible query builder, and here it will be user. The user can be get from a dependency called current customer, and this can find current user. So by this way, by this way we can very easily return all the products the controller wants. But there is a different there is a different object we want to get. We don't actually want to get products, but we want to get product details. You can see the other methods. They are returning either pagination result, which is useful when you need to use pages for your listing, or it uses array of product details, which are basically products, but they are enriched with more information about price, about images, and they are more friendly to use in the Twig templates. So we will just put these products into a product detail factory, which can create the product details for us. And now it will return array of product details. We should rename this method to get recently bought product details. So now we can use it in our controller. Fetch these product details from the facade and insert it into our template like this. In our template, we can import a macro that can be used to list these products, because listing products is something the whole eShop is doing. So there is definitely useful macro for this. So you don't have to implement it on every page. So we can look for the macro. It's called product list macro here on the front content, and we can call it product list. And now we can use it actually quite easily by calling product list with the product details provided by the controller. And of course, we shouldn't list the products under the message that we don't have any. So we can write here and if condition, if this is empty, we want to show the message, and else we want to list the products. And now, hopefully, when I visit the recently bought page, I should be able to see all the products I bought, which is great. There are some extra things I should do now. In the product repository, I should. How is the time? Oh, we are slightly behind schedule. So I can skip these steps because we have now it pretty much working. I can show you some extra things. First, I should really call standards fixed diff. So there is no violation of coding standards. Now I should probably make another commit. So recently bought product page is actually displaying products. And one thing I wanted to show you is the smoking tests. So I will call think test smoke, and we will see that the test will actually fail. You might have noticed this, because I made a mistake by intentionally. It now can say that there was a type error in the product repository. That's because in the product on current domain facade, we are using here a find method, which returns either user or null, and are providing this user or null into the repository, which is type hinted as user, and this cannot be nullable. And because in smoke tests there is no locked user at the moment, we can see it fails. So I can do here a very easy thing. When the user is null, I can just return an empty array because I know he didn't buy anything. When I run test smokes now, it will pass. But now it isn't really covering our use case, because the smoke tests are not actually testing the product repository. It always returns empty array, and nothing is ever displayed. So if you imagine I throw a new exception here, the smoke test would pass even now. So to cover this, I can go to the smoke test customization. Route config customization in the smoke test namespace, and here are some configuration for the actual component, and we want to configure the front-end route we just made, so it uses authentication. So we can basically add a call at the end, customized by route name. This will accept our route name, current product recently bought, and a callback. And that will have route config, so we can customize things. On the config, I can call function method add extra request dataset, which means that this route will be tested in more ways than just the default one. So here I can optionally make some comment on this extra scenario. So recently bought products of registered user, and for this scenario, I can provide an authentication basic HTTP out, and I will provide the credentials from the demo database. And now, when I run the smoke test, I will see that they actually failed, because there was an unhandled exception. And we can see that there is one more test, because there is the extra scenario. So we can see that it expected 200 OK, but got 500 internal server error, and we can see the note we written, extra test case, recently bought products of registered user. This can help us when debugging. So we can fix the bug and make a new commit. There is not really that much time, so there is not enough time for nice commit messages. I want to show you because I want to show you another thing, and that is the translation. We have all this page just in English language, and when we visit it on the second domain, we can see that it is in English, not in Czech. So I want to fix that. So to fix it, I will run think dump translations, which is a target that will go through all the source codes and look for translatable messages. It will extract all these messages into a PO file, which is used by translators, and we can then add the Czech translations ourselves. These translations, as I said, are in PO files, So you can see them here in the resources folder and translations subfolder. There are messages. There are general messages, and there are messages in the form validators. We can see that the check extractions is already done, and I will look for new messages in the file. I can see here recently bought, products, and translate everything. Nedávno nakúpené produkty. I can see here there is another modification. You don't have any recently bought products. Nemáte žádné nedávno nakúpené produkty. And these should be almost all your recently bought products. Okay, now I should have everything translated. You can see that in the English file there are also the extracted new messages, but we don't have to translate this. And you can see that on the Czech domain, it's now everything in Czech, not in English. So we can make our last commit. Czech translations. And we are done. We can see now everything works as expected. We can do some more extensions, but we don't have actually time for that. If we want to discuss your questions, because that is the last part of our presentation. We would like you to try it out and give us feedback, not only on the Shopsys framework as a product, but also on this workshop. To do so, we would like to send you a feedback form, and of course the slides and the recording of this workshop, so we can return to it and watch something you didn't quite get. So please send us your emails, so we can send the files to you. And this is everything for us from us. If you have some questions, don't hesitate to ask. You can do so now or later via email, or you can join us on Slack. We have automatic invitations on slack.shopsysframework.com. So if you go to this address, Slack Shopsys Framework, you can see there is input for your email address, and we can join you to our Slack group automatically. Mirek, do we have any questions?
No questions yet.
Okay, may I have some?
Yeah, sure.
Okay, so my first question is about get recently bought products. Shouldn't it be find recently bought products? We consider that we can have registered user without any order.
Yeah, that is good question. but we will see the project repository. The get and find prefix is only mentioned when there is no array. The get means it returns either entity or array of entities. It can be an empty array, doesn't matter, but the find means it returns either entity or a null.
So, or ISS error or something exception. Okay, I see. Second question is about the smoke test, config customization.
Yeah.
I would like to know if there is a specific reason why we don't have setting for user. Why do we have to set up the login user all the time again and again? Why is there no pre-configured registered user we can use for all the tests?
I'm not sure what you mean, because there is a pre-configured default values like do not authenticate and expect status code 200. So what do you mean by prepared configuration?
For example, there is a set out, and I have to put the credentials again and again for each page which needs the authentication. So why is there not any kind of logged in user, logged in administrator I can reuse again and in all the cases? So I don't have to put credentials on 20 places or 10 places.
I understand your question. So this can actually be done. You can see here there are some pages that are meant only for the registered user. So you can use an array of routes and reuse it like this, or you can use, for example, regular expressions like in the admin section. So you can customize. So you can use just one customization rule to set the authentication as a default setting for all the data sets.
Oh, okay, I see. I was just surprised to see it on so many places inside the same credentials, actually.
Yeah.
Okay.
I understand, but it's actually quite readable, because in the administration that there are, for example, some pages that only super admin can access. So you want to use different credentials, and of course, if you want to, you can put this in some private method like get admin out. And
okay, that was it. I was actually asking a specific reason not to do so.
Yeah.
So I see I can do it, so no problem. Okay, my next question is about friendly URL processing. So I would like to know more if there is some kind of information or manual. How is it working?
At the moment, there is no actual manual or documentation, but if you see the routing friendly URL YAML file, you can see a link here to the method that to the class that actually does all the stuff.
Oh, okay, I see. I didn't see that.
You can at least go through the codes yourself.
Okay, so next question is if I can obtain original image, as it is working with many images. In some specific cases, the customer demands or requests using of original image without any compression, any resize, simply as they put it in administration, they want it on the page.
Yeah, the images component saves the original files all the time, because it is important when you, for example, change the dimensions you want for your default size to some bigger ones, so that the eShop is able to reconstruct the image without any loss of data. So it is always saved. I can look into I can show you in the web folder. I believe there is content, images, and for example product. There is always the original folder, original directory with all the original files.
Perfect. And am I able to access it easily in the Twig template?
Mirek, correct me if I'm wrong, but I believe that you can use the keyword original as an actual size, as you would use, for example, gallery thumbnail, and it will output the original file. So it is actually very easy.
Perfect. Okay. Sorry?
Yeah,
go on, please.
Because I think the original images are used for the gallery, I think. Like if you open the image on full screen, I think it's the original one that is used.
Perfect. So the next question is about your sexy form type components. Do you plan to move into components any other than the file upload? For example, the multi-domain and so on.
You mean if we plan to move the form types
to a component?
To a component for them. Yeah, it is. I think it will be possible, because form types are quite like separated class, so it can be moved. But the thing is that the multi-domain functionality itself is part of the core, and to use it anywhere else, you will also have to make the multi-domain functionality as a component, which I don't think is really easy. But maybe it could, because it is something similar like the translations, for which there are bundles. So it could be possible, but the form type itself, it's easy to separate as a component, but the multi-domain functionality is actually part of the Shopsys framework, the crucial part of it.
I see, but for the translations, it's no problem to put it into separate components, so it can be out of the core.
Yeah, we actually use a bundle for translations. Like I think it's I'm not sure about the name. It's maybe present translation bundle that we use for the translation. So it is actually a separate component. We just add some other features there.
No problem. I can find it in the source code. Okay. Last question: is there any functionality allowing to move shops between servers? For example, I have a client who is taking 60% of my server capacity, and I want to move him to another server. Is this possible? Are tools for this available?
Well, tools. Basically, if you want to move the application, I don't think that we developed any specific tools for this use case, but it should be quite easy because I would do it in such a way that I would run a separate instance first, copy the database, just basically do a dump of the database and put it on the new server, and then you will need to do some switching from the old instance to the new one. For example, using some reverse proxy like Nginx or something like this to be able to switch between those two like fast. Or you can change the DNS records to the IP address of the new server, but this can.
I see. This is the process itself, but I've been thinking that you can have more clients, more shops within one database. Am I wrong?
Yeah. You can have multiple frontends with one administration and one database.
Yeah, so basically I would like to take the client from one client, one eShop from this database. Where is he among with other clients, and move him to another server between another clients. So this was actually the question. Mm-hmm. Because of the scalability, you need to move clients between servers time to time in order to maintain a low cost hardware, or how to explain it.
Yeah, the multi-domain functionality is not actually meant to be used as completely different eShops. But to be used as just different front ends of the same eShop. For example, language mutation or some specific brand presentation with limited product catalog. So this is, if I understand you correctly. This is
I was wrong taking the question.
Actual use case, because when you look into the administration, you can see that as an admin, I have the access to all the products on all the domains. So this is not really good if you want to run completely different eShops in this way. We would recommend to just make a new instance of the source codes, and you can then manage it pretty easily.
Yeah, I see. Okay, taking the question back. That was all. Thank you very much.
Thank you for the questions. Is there anyone else with the questions? Do we have anything in chat?
No questions in chat. Yeah. So if nobody else has any questions, please. It's the last time to send us your email addresses through the chat so that we can send you the slides and the recording of the presentation. And if there are no more questions, then thank you for your time. Thank you for joining us today, and have a nice day and have a nice weekend too.
Yeah. Bye.